Hi guys, it is Mr. Dave and
Science Haley.
Bing! And we are with the RayKitty Science Project, and we are coming from RayKitty Creation Workshop, and we are here to do some fun science. We have some stuff you can do at home, and some stuff that if you happen to have one of these, you can do at home. Yeah, none of this is dangerous. It is a little bit
Shocking.
shocking. Oh yeah, there you go. Because we're going to be talking about electricity. Okay, and electricity is wonderful. It powers my little bitty watch here. What else does electricity power? Our microphones.
That TV.
That TV. Now, speaking of that TV, while we're doing some of these demonstrations, you may see that TV flashing on and off. We are going to be generating a high static electricity aura, and it may affect the signal. We didn't break the TV.
Promise.
All right, so no, but just as a heads up, safety for this one. There's balloons. Don't eat balloons.
Probably don't eat anything on this table right now.
Yeah, don't eat anything on this table. You can see we have little dots of styrofoam and things like that. Yeah, don't eat any of this. When we're talking about electricity, we are going to be working with electricity, and we are going to be doing it in a safe way. I say that, but do not, if you're working with electricity at home, make sure that you are, you do have a parent around. That doesn't mean dad's sleeping on the couch, so you go and take something and stick it into the outlets, okay? So you want to be careful with electricity. The odds on messing with one of those outlets, on it actually electrocuting you and doing harm is pretty slim, but it can burn you very, very badly, very badly. So you don't want to, we want to make sure you guys still have all 10 little fingers. So be careful anytime you're messing with electricity. Now, I mentioned the wall outlet here in the United States. Our little wall outlet, about how many volts are those wall outlets usually?
110 to 120?
Yeah, like 110, 120, okay? So 110, 120, and that's what we plug things in. And then you have your higher 220 for it. But normally in your house, when you see that little thing that looks like a face going like this, that you're plugging things into, that's usually a 110, okay? Now this that we're dealing with here is, do you remember? It's been a while since Haley helped me.
I do not remember. How much, Mr. Dave?
Oh, there you go. How many volts is it? So this one here is about 10 to 20,000 volts.
That's a little bit more.
That's a little bit more. Now, saying that, when we turn this on, we are not going to end up flying across the room like Marty McFly, anything like that. The voltage and the amperage or current, the voltage and the current are two completely different things. I'm going to have you work that, and I'm just going to explain what's going on. So Science Haley here has got a little tube, okay? Now, this is actually the very first time we've done this one. So if we fail miserably and you're at home, you can rewind it again to watch us fail again.
Exactly.
Yeah, because that's what that's all about. No, but what this is going to represent, if you could hand me a couple of those little, those are airsoft pellets. Yeah, if you could hand me a couple of these little beads here. This little bitty bead is going to represent an electron. Okay, so you can pour some of those beads in here if you'd like. Oh, keep going. That was fun. All right, so that's pretty good. All right, so these little beads will represent electrons. Now, when we talk about voltage, high voltage, the voltage that is something is rated at, voltage is only one way of measuring electricity. Okay, the other is current. Okay, now one way I like to explain it while you're putting that together, you just screw those on the end.
It's not screwing on the end.
It's not screwing on the end. Oh, go get the other part. She's going to go get the other part. So these here are supposed to...
Oh, okay. That's why there's two tubes.
There you go. See, that was what we figured out. Yeah, science. There you go. So what we have here is this is representing our source of our electricity. We'll back up a little bit here. And see, that's why it's a team. So we're a team. And so this is representing the source of our electricity. And so this is what has those electrons right now. In the case of our Van de Graaff, we're going to take them from that. Is that one doing okay? There you go.
Almost. There we go.
All right, cool. So right now, and you can hold that side. We'll work like a team. So when we are doing that, there you go. Perfect. When we're doing this one here, we have those electrons in here. Now, the voltage is going to be what?
How much we tilt this?
Okay, so if we tilt it a little bit, This is low voltage. Okay? So those electrons are flowing, but it's a low voltage. Now, if we wanted high voltage, we would, and so that is high voltage, a lot of those electrons moving at the same time. Now, when we have just a few beads like we were doing, okay, that is the current, okay? Now, we don't have a very high current here, and so the current, I kind of like to explain it, the current is, well, the voltage is the size of the boot, the current is how hard it kicks you. So right now, we have a low current, but we have, and also a low voltage. If we had a whole bunch all in one side, okay, now this is going to be high current, high voltage. Yeah, so that was a whole lot of that electricity moving all at once. So that is high current and high voltage. Now, we mentioned that this thing here is about 10 to 20,000 volts. That's a lot of voltage, but what if we move down to a very low current so there's not as many of those electrons moving? We have a low current, but we're going to do a low current and a very high voltage. Okay, so I'm going to put this back on here. There you go. And so if you were to do a very high voltage, you just do it because that's fun. There you go. Yeah. Boom. Right? So we didn't have a whole lot of those electrons moving, but it moved very, very quickly. Okay? So that high voltage is a lot of those electrons moving, and they're moving very freely. There's not a lot of resistance there. If we were to pinch that pipe there, I would be angry because I just purchased this. Oh, no. If we were to pinch that pipe, then we would have resistance, and that would slow down that current, okay? But because it flows nice and freely, here, do it one more time because that was fun. All right, so there you go. Give us high voltage. There you go. Now give us low voltage, low current.
Takes a minute.
There we go. Good. So what you're seeing there is our difference between the current and the voltage. Okay. Now the voltage, you can have a very high voltage, like say this is like 20,000 volts, 10 to 20,000 volts, depending on a lot of weird factors.
The weather?
The weather, the way that my cord is ran, the material of the table.
If it's touching the table?
If I used a lot of hair care product that day. Yeah.
All actual things that can mess with that much
Those
voltage.
really are things that can change that voltage and the way that this is going to react in the environment. So when we do this one, it could be either, yay, that was amazing, or it can be like, wow.
Science.
I sat through the whole thing. Yeah, no, but there's really a variance. Okay, so when we do this, we're going to bring this one up. If you could, here, just hand me that guy there, and I'm going to pole vault with it. No, I'm just going to set this one out of the way. Right over here. Wait, one more time.
One more time.
High voltage, or no, wait, high voltage, low current.
Other way.
Okay, so I'm going to just set this back here for now. And these little guys here, these are also going to represent those electrons. You can see these are a little bit bigger ones than we had before, but we're going to use those to kind of represent the same thing that's going on. What we're talking about with electricity, that was a lot of high current, high voltage, all that kind of stuff. We're going to mainly be talking about static electricity. Okay? Static electricity is different. Why is static electricity different?
Because it's not running consistently.
Static. It's static.
Static.
Yeah, static means it's going to stay still, right? And the static electricity doesn't always stay still, but it will build up on something until it is reached a point to where it can discharge. Okay. Now, just the other day, we saw a beautiful lightning storm here in New Mexico, and I love the lightning storms. And you see the off in the distance. Yeah, that's a scientific term. It's like this. Yeah, there you go. So you see that off in the distance, and that is actually static. It's the same thing that you're going to see happening here. This is just on a lot smaller scale. Okay. Now, I'm going to bring this guy over here. This is called, well, first let's do it with let's do it with these first. Yeah. So what we're going to do with this balloon, this is one you can do at home. You blow up a balloon and then you rub it on, and then you
Might be easier.
You blow up a balloon and you, well, you get it all greasy.
Use this one.
All right. I'll let her do it. No, but you rub a balloon, or you blow up a balloon, and you can rub it on your head.
You can rub it on my head.
There you go. You blow up a balloon, and you rub it on your head. Okay, that's fun. Now, Haley has all of this nice, beautiful, thick hair, and I told her not to put a lot of stuff in her hair, but you can see here that her hair is attracted to the balloon. Okay, what we have here is her hair is getting staticky, right? And because electrons carry a negative charge, when we're doing that, we are moving those positively charged ions, and our negatively charged balloon is saying, "Come here, Haley's hair." I don't know if it actually says that, but that's what's happening there. So it works like a magnet because you have positive and negative. So the negative is attracted to the positive. Haley's the positive, and I'm the...
Oh, I think you're the
positive too. Yeah. All right. So,
and the negative don't like each other.
Right. So they're going to repel.
Disperse.
Yeah, they're going to disperse. So when you have negatives, they are trying to get away from each other. Just like when you have two magnets. Here, I have a magnet. You have a magnet. Now, if we had the negative side, well, this is our imagination. If we had negative, this side was negative, this side was negative, and we would.
It wouldn't.
Right. They're not going to stick together. So that happens with electrons too, and that's going to happen on this shiny dome. Now you saw it didn't happen on this shiny dome. We're going to go for that shiny dome. So this is called a Van de Graaff generator, and that's because it generates tiny little Van de Graaffs that just run all over. No. That was the name of the inventor. But what this does is it actually moves around those positively charged ions. I'm going to move this to the center here, and then we'll make sure that we're not in the way. But I'll move that to the center. But what we have is just like when we rub that balloon on Haley's nugget, this belt in here is going to do the same thing. There are little wire brushes on the top and the bottom, and this will actually collect all of those little positively charged ions, and they will distribute them on this shiny dome. So they'll ride right up this belt here, right onto this shiny dome here. Now when they're
not this shiny dome.
This shiny dome. So when they're deposited on here, they are trying to push away. You've got those electrons, same polarity, and they're trying to push away. So we're going to turn this on, and you may hear a little bit of crackling and popping. I'm going to put my arm up here. Let's see. I'll see if I can get to where you guys can see it on the camera there. And let's see. Can you guys see it up there? Okay. There you go.
There we go.
So what's happening is that little lightning bolt, and you can see my arm twitching, just like the one where Haley was electrocuting my hand. The same thing is happening here. Our bodies are electrical. And so when we see that little lightning bolt jump to my arm, it's actually activating that muscle, and it's making my little muscle twitch there. Oh, there you go. If we just get just the right distance. There you go. Now you got a nice little strong lightning bolt jumping there to my arm. And so when it does, what's happening is it is actually getting covered just like in a lightning storm. Those ions are building up and they're looking for a negative. Now I've got this one here, and what this will do is this one here. You can hold that one because it'll be a little further away. And then when you hold it closer to, you can see that little lightning bolt jumping up from this one to that one there. There you go. And you see that lightning, that static, those electrons as they build up, they are working to force away from each other, and when they do, they are jumping to this little bitty ball here. Okay, so what we're going to do now is we're going to see those electrons. This is kind of a demonstration of those electrons. These are a little bit bigger ones, and we're going to put them in this little thing right here, up top. Okay, and we have those electrons, and this is kind of a demonstration of what is happening with those electrons. Now, they are bouncing around in this little ball here. I'm going to try and get out of the field so we have a little bit more energy there. So they are bouncing around in this little beads, or these little beads are dancing around. You can see them floating in there. And what's happening is they are pushing away from each other. So they're trying to get away from each other. Just like if you've ever been on a road trip with your family and you've been in the same car for a week and a half, they're just trying to get...
Just trying to get away from each other?
They're just trying to get the chips.
Yep.
Yeah, all right, so, yeah, the same thing is happening there. Now, what I have here is I have a little piece of ribbon, okay, or a little piece of...
Tinsel?
Tinsel, yeah, tinsel. And what you do with the tinsel, this is purple tinsel because I like to feed it to my purple cat. No, don't feed your cat tinsel. But what we have here is you can see this will actually become charged. Okay, so this is going to have kind of a strange little effect because it builds up a charge and then it discharges. So we can have it sometimes, we can bring it down here and we can see if that little guy will dance around. Oop, there you go. We'll dance around on our little Van de Graaff there. And, oh yeah, there you go. So you can see this guy wants to be by it, but then it doesn't want to be by it. It builds up and then it discharges. And so this guy, let's see, let's come back over on this side here. There you go. Let it build up. And
it falls down.
It falls down. There you go. I got it. Yeah, you got to get it right in the right spot. And this little guy will dance around in that charge there because it is building up with those electrons and then it is being discharged or discharging those electrons. So you can see it there. It's like, I want to be by that, but I don't want to be by that. Now, what's kind of fun about this is you can also do the same effect with, oh, it likes me. There you go. With someone's hair. Just like we did with the balloon. Now, I brought Haley with me today because she has hair. Yeah. And so what we see here, I want to kind of explain what's going to be happening, or hopefully will be happening with Haley, is you see as this is building up, it's actually repelled from the little Van de Graaff there. So you see it kind of bouncing around on there. And then you, you see the screen behind us. Yeah. So when we have Haley here, and we're going to get her closer to it, we'll bring Haley up, and we have a little step ladder. Now, you won't be able to see the step ladder. It's behind the desk with us here. But that step ladder is going to remove Haley from the ground.
Pretty much just floating.
Because that's what step ladders do, is, yeah, they make you levitate. It's just that you're levitating while you're standing on something. Yeah. No, but what that's going to do is it's going to isolate her from the ground. So when we put her on the step stool, it's not to make her taller, because she's already almost taller than me, and I don't like to talk about it. But it is you're going to see that she'll be a little bit taller. The reason she's taller is she's going to be standing on this step stool. Now, the step stool is going to keep her from the ground. When it keeps her from the ground, the electrons that are building up on her are going to have a hard time escaping. Okay? They're going to have a hard time getting away. So when she's on the step stool, it will allow them to build up on her, and we'll see what happens. So I'm going to bring the step stool over. I'm going to put it this way because you don't want it too close to the table there. If you could just, just on that step, you should be okay. Now, don't put your hand on it. Now, you'll notice when I was getting close to this thing here, I did not put my hand on it while it was on. Okay, you'll see now. Don't reach in there, but you'll see that I've got my arm about this far away. Okay, and we see that popping happening there. That electricity jumping to my arm, and I'm staying about this far away. Okay, so yeah, you can see it jumping to my fingers. There you go. Yeah, and even my little fingers are twitching a little bit. So when it is on, I'm keeping my hand a little bit away from it. Okay. So Haley, go ahead and keep your hand about like mine was. Now, so she's got her hand about the same distance. We're going to change it up, and she's going to put her hand right on there.
Oh, no.
Oh, no. Now the difference being when her hand is on there, okay, those electrons don't have enough energy to build up because instead of just being on here, they are also now covering Haley. Okay, so when I turn this on, we're going to listen. Okay, now this doesn't quite work in the studio or in the lab. That was a good one. But normally when we do this in front of an audience, what I'll do is I will be very quiet and I'll say, okay, 3, 2, 1. And when I turn it on, I yell, pow! But I won't do that now. But it really is funny because you see the entire everybody jumps and then the person that's standing here dies. Now...
Nobody's actually died yet.
Mostly. No, this is a safe one. But I did turn it on here. And we're going to see if it works out for those electrons to actually end up covering Haley's head here. Now, go ahead and shake your head around a little bit. I see that we are changing that screen to lots of different colors back there. Let's see. So what we see now is I'm going to get close. Yep. I'll try not to shock. If you turn your head toward me, you can see on the back there her hair has started to raise up a little bit. And you can see that her hair is now attracted to my hand. Now shake your head around like you're in a shampoo commercial. There you go. And when she does, you can see that her hair is actually beginning to, I'm just freeing up the hair there. She's got that nice, beautiful dandelion effect going on her head there. And what's happening is all of those little hair strands are now covered with that electricity. And when it is covered with that electricity, her hair is now pushing away from each other. Now, I'm going to sneak around to the other side over here. And what we'll be able to see is she can now, so if you can see that there, her hair is starting to really stick up and look like a dandelion. Now go ahead and turn your head away from me for just a second. There you go. And you'll see that hair is actually attracted to my hand. So you can see that hair wants to find the opposite polarity. Now, because I have the opposite polarity, she can also, she's going to shock me on the head. So what we'll have her do is we'll start with just a little ET fingers. If you want to kind of just focus in right here, we'll start with just a small one, see how she does. Oh, there you go. Yeah, so we got a little one. If you want to do a little bit larger one, you can go elbow. Don't elbow me in the head. She's going to elbow me in the head. Boom. So there you go. So we'll see if, whoo, there you go. We'll do it one more time. There you go. I'll move in nice slowly. Woo, there you go. And this is why I can't do math. No. So what's happening there is because she has all those electrons, it is now sharing those electrons with me, right? So she's building up with those electrons and they are moving over to me. Now, what I'm going to do is I'm going to come back around over here. And you're going to keep your hand on there just like it is. We're going to turn the Van de Graaff off. And if you get real close, you'll see that her hair is now returned to normal. Except it hasn't, right? She still has all of those electrons covering those hair. And that's because she is still elevated or isolated from the ground. So if you step off of that step stool, please go down, please. All right, there you go. Now, you'll see that her hair kind of returns to normal there. Now, I'm going to scooch this guy out of the way. So what we're working with here is the electricity, all of those electrons, we're moving at a different rate, right? We have a whole lot of that electricity happening all at once. And so that is a very high voltage. Good. So we have a very high voltage, and that high voltage is that electricity moving very quickly. Okay. So when we want that electricity to move quickly, we have this static buildup. Just like when, have you ever been on a slide? I know you've been on a slide because I took her on a slide when she was little bitty, and then we went last week. No, but we still play at the playground. But when you go down a plastic slide, back in my day, they used to have metal slides, and those were just torture devices. But nowadays, they have those plastic slides. And when you go down a plastic slide, right, you're on the slide, and then you have to do it like, what do you do when you're on a slide? You go, wee, right? Wee, when you're going down a slide. And when you're going down the slide, Oh, on you. Yeah. When you're going down the slide, it's just like this right here. You are generating that static electricity as you're going down the slide. Slide, 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 slide. And then you go to get off of the slide and all your hair stands up, right? And then when your feet touch the ground, and poof, it shocks you on the backside, right? You guys know what I'm talking about. And that's the exact same thing that's happening here is those electrons, as they're building up, you're getting covered with those, either the positive ions or those negative electrons. And as they're building up, you are getting that static electricity. Or when you jump on a trampoline, okay?
Yep.
When you're jumping on a trampoline, you're like, whee, I want a trampoline. I do that on trampolines too.
Yeah.
I do that on everything. But anyway, so you're jumping on a trampoline, you jump up and down a trampoline, and then you go to get off the trampoline, same thing happens, woohoo! Right? But when you're getting off the trampoline, what happens with your hair?
Boom.
Yeah, so her hair sticks to the trampoline, and then when you get off the trampoline, all your hair falls down. I was going to say out, but that was me. I appreciate your patience with this thing going over here. Our static is messing with the signal on the television. But what we talked about was current. We talked about voltage. Okay, and then we messed with static electricity. Okay, so again, my name is Mr. Dave, and this is
Science
Haley. And as we end everything, don't forget that science shows you matter.